one admittedly rather complicated part of C++ is the fact that you can actually overload operators that allow you to do kind of strange things. So for instance, the assignment operator, when you use that single equal sign, that's actually an operator. It's actually a function call, and you can adjust what happens for that function call. There's also the ability to adjust what happens when a copy of your class is made, as well as what happens when your class is actually destroyed. These three parts, the assignment, copy, and destructor, form together what's called the rule of three, which I'll talk about more in a little bit. But first, let's talk about the last of those three things. Let's talk about how to control what happens when your object is destroyed. So the way the particular C++ implementation works for how your object is destroyed is called defining a destructor. This is a function that's called when your object will be destroyed. Now, when is your object destroyed? Well, it's kind of like the opposite of constructing your object. If you can define constructors that says, okay, when your object is being constructed, these are the things that happen. You might define a default constructor, you might define some conversion constructors, you might define other sorts of constructors. Well, if you do particular work when you're constructing the object, you may want to also do things when your object is destroyed. And so the way to do that is by defining a destructor, a function that's called when your object is getting destroyed. You might go, well, when will things get destroyed? Well, when variables go out of scope, meaning like a local variable to a function or something like that, when their function ends, all those local variables are destroyed. And those local variables may be instances of your custom class. And you may want something to happen when those variables are destroyed. Or if your custom class is an instance in a container, like in a vector or something like that, when that vector is destroyed, it calls the destructor on all of its elements. The other time is when you have dynamically allocated objects. This is something we haven't covered yet. But when you call delete on these special objects, then the destructor is also called. So how do you define a constructor? Well, you say tilde followed by the class name, and this is a function that doesn't take any arguments. And like the default constructor, if you don't provide one, it's automatically provided for you. In fact, every strut and class that you've written so far has a destructor. It just is using the default synthetic constructor. And in general, you don't need to define a custom destructor because the default behavior is probably already what you want. Built-in types are destroyed correctly. The STL types are destroyed correctly. Really, most of the time when you have a class, what do you want to have happen when it gets destroyed? You just want to call the destructor on each of its data members. That's already what happens by default. The one time that you are, well, not the one time, but the most common time when you might want to write a default destructor is when you're dealing with dynamic memory. Once again, this is something that we haven't covered yet. And the rule of three is the idea that if you need to have custom behavior that applies for your destructor, like you want to have something special that happens when an object is destroyed, you probably need to also have special behavior that happens when you make a copy of an object. Because if something special needs to happen when something's destroyed, something special might also need to happen when you make a copy of an object. Or when you assign to an object. If you assign to an object, you probably need to have something special happens there. The rule of three is that if you need to write custom versions of any of these three members, or these three different functions here, you probably need to think carefully about needing to define each of the other two. And generally, once again, the defaults for all three of these is probably what you want unless you're doing stuff with dynamically allocated memory. But just for thoroughness, I'm going to show you how to do those constructions now. So once again, I'm repeating this because I want to make sure it's really clear. You do not have to write any of these member operations. The copy, the assignment, the destructors, the default almost always is what you want. Unless you're doing stuff with dynamic memory, which again, I haven't taught you yet. But this is mostly preparing you so that when we cover dynamic memory, which is going to be the next thing that we cover with regard to classes, that you've seen these member operations before. Alright, the other thing that I should mention is you have the option to say that you don't want the default, you don't want one of these member functions to actually be defined. And the way that you do that is you say equals delete. What does that indicate? It says do not include one of these member operations. So for instance, if you say that you don't want the copy constructor to exist, you would specify the copy constructor, which I'll show you in a little bit, and then you would say equals delete, meaning that nobody is allowed to invoke this copy constructor so that you can't make copies of your class. Now, when would that be useful? So for instance, streams, it generally often doesn't make sense to make copies of streams. It makes sense to refer to them by reference, but it doesn't make sense to make a copy of a stream. And so a stream could delete the copy constructor so that you're not allowed to accidentally make copies of a stream. So what does a copy constructor look like? Well, a copy constructor is just another constructor, except it takes one parameter, which is a reference to the class itself. So it's like a conversion constructor, except it takes its own self as an argument. And what C++ does by default for the copy constructor is it does a member-to-member copy. So for every data member in the argument, it's going to make a copy of that into the new constructed instance. And this is exactly what you want pretty much all the time, except if you have dynamically allocated memories, which is like having pointers in your class. Now, because making a copy of a pointer, meaning it's not copying the thing that's being pointed at, just copying the address of a pointer, probably isn't what you want your class to do. Maybe it is, maybe that's the behavior you want, but it may not be. But to be honest, for almost anything besides pointers, a member-to-member copy is probably the functionality you want. The other thing to mention is assignment. Now, when you're copying something, that's almost the exact same thing you want to do when you do assignment. They're pretty much the same thing. And the default assignment is to copy each of the elements from one thing and make the thing that's being assigned, the thing that's being changed by the assignment, make that member for member the same as the thing that it's being assigned from. The only thing that's different is that assignment allows for chaining. You're allowed to say like A equals B equals C. And what that means is that you have to return from a copy assignment a reference to the object that was just assigned to. And I'll show you an example of that in just a bit. So let's back up and look at our clock header. So here's our clock header, and we've covered pretty much everything that's in here. We have our private data members here, as well as our private member function. We have constructors, and note here is our copy constructor right here. And now once again, it's a constructor because it has the same name as the class. It's just taking a constant reference to that class. And we're going to be defining it on a later slide. Here is our destructor. Once again, it starts with a tilde, the name of the class. It doesn't take any arguments. And we're just using the empty destructor here. To be honest, this is what's done kind of by default. I could have just had this line not here and the code would do the exact same thing. All right, what else is new here? We have our assignment operator right here. So we're operator equals. And what the assignment operator does is it takes a constant reference to a clock and returns a constant reference to a clock. And it should change the object that this operator is part of. The add minutes and the operator equals, these are both member functions. And we have here is our friend function, which again is not a member, but it's just a friend function here for the plus that we've already talked about. All right, the other thing is we have a couple regular functions here. These aren't even friend functions here. So we have the operator plus, we have the operator less than. Once again, we've already shown these ones before. So how does the copy constructor work? Well, the copy constructor is just a normal constructor that just happens to take a constant reference to a clock. And what it's doing here is we're actually doing what the automatic copy constructor we're doing. We're doing a member for member copy from our argument into the object that this member function is part of. So we're just copying the minutes, we're copying the hours, we're copying the period. Once again, this right here is doing what is the default value. This isn't actually accomplishing anything because this is what would happen automatically. But if we wanted to do more complicated things here, we could. We could have had this do things besides just a member-to-member copy if we wanted to. Over here, we have the assignment operator. We have operator equals. And now note, the assignment operator is a member function. Why is it a member function? Because the assignment operator changes the one of the objects that it works on. Notice it takes one argument. This is the right-hand side of the assignment. And the left-hand side is the member, is the object that this member function is part of. And what does the assignment operator do? Well, it does a member-for-member copy, or really a member-for-member assignment here. And then the last thing is it returns a reference to a clock. And you might go, well, what should this clock be? Well, this is really the clock that was just assigned to. And so how do you return a reference to this clock? Well, you need to return this. Now, you can't just say return this because this is a pointer, and we're not returning a pointer to a clock. We're returning a reference to a clock, so we need to dereference the pointer so that we get at the actual object, and we're returning the actual object. So we're returning the dereference this, and we're returning a reference to that. So once again, the assignment operator is a little bit complicated. I'm going to go through it one more time. It takes in a constant reference to a clock, and it does the assignment. Like it changes the object to have the same values as C here, and then it returns a reference to the the object that was just changed, which is by dereferencing the this pointer. And the reason why I spend so much time teaching you about the this pointer is really so you can understand this one line. Most of the time, you don't have to be explicitly referring to this. You don't have to say, this arrow or this dot. But right here, the assignment operator is one time when you do need to use this because you need to be able to return a reference to the object that was just changed. And now, with all of the changes that we've made to clock, our main function can actually do some complicated things here. So for instance, we can call the default constructor on a clock. We can call our 3-argument constructor on a clock. Here, we're making a call to the copy constructor. How do I know? Is because I'm trying to construct a new clock out of another clock. This is calling the copy constructor. I can see out some clock because we've defined the less than function. The other thing is I can do assignment with my clock. Now, I could have done that before because the default assignment operator works just fine, but I can still use the assignment operator because I've also defined it. The other thing is I can also add clocks together because I defined the operator plus for adding clocks together.